So, right, we are now recording. So, good morning to everyone. Thank you for joining. Particularly, I should say, good morning to Geoff Huston from APNiC, who's the chief scientist. So, good morning, Geoff. This call was prompted by an exchange on the Eddy list from, I think, a couple of weeks back. Where in response to a question, I think it was from Glendine, Geoff put up a post with an outline of the sort of the measurement methods that APNiC uses, and I thought it might be beneficial to actually bring that to life a bit, and then maybe allow for a few questions on it. So the purpose of the call this morning is purely to focus on that. So we'll run through that and then take questions at the end. So what I'm going to do, if I press the right buttons rather than the wrong buttons, is I'm going to put your slides on the screen, Geoff. You might, for anyone that's not familiar with APNiC, it might be useful perhaps first just to start by introducing the APNiC labs and then go through the presentation, if that's okay. But I'll put your
Okay, Andrew, look, while you put the slides up, then I'll quickly introduce myself. I'm Geoff Huston. I've been working with APNiC as their chief scientist since, God, forever. 2005, that is forever. Part of the reason why the job was actually established and the reason why we do this is to actually sort of understand the effects of all this policy making about addressing. And so the first thing we started to look at was really the issues around routing and IPv6. We wanted to understand, over in the policy room, they do the policy thing, and we're trying to understand what the results of that policy was. Does it work? What was effective? What was not effective? And, you know, we started looking at BGP, we started looking at a bunch of things, but we were really perplexed about what V6 was all about. And in particular, you know, who's doing it? And then ended up being a sort of a meta question. How do you measure how the end user does things? Because we're so good about measuring our own equipment and our own infrastructure, but actually understanding end users is an entirely different game. So I'm going to go through this pack relatively quickly to leave lots of time for questions. But I want to sort of focus on how we measure and what the essential elements of this measurement system are that is different from almost every other measurement system I've ever come across. Next slide. So, you know, what do we say when we're saying we're measuring the internet? You know, what does it actually mean? Next slide. As you see, it sort of goes quickly here, Andrew. You know, part of this is trying to actually create repeatable metrics, but at the same time, next slide, what you really want is actually measurements that talk about what users actually experience. So rather than my router did this or my router did that or my server did this, what do users actually experience when they do things? How fast is it? You know, what actually happened? And just as importantly, is it different where you are and sort of where the service infrastructure is? So in practice, what we'd like to do is measure the entire internet all of the time. And last and not least, I am sick and tired, and I think everyone is, of saying, well, we know that, but we can't tell you that the data is private. Google is very, very good at that, but they're not the only one. Most data is actually owned by someone. And so what we'd like to do is create these public measurements that sort of look at the internet from the user's perspective, draws across the entire internet, but actually doesn't use private data. It actually tries to make this as public as possible. Next slide. So we started because a whole bunch of people were saying a whole bunch about things about V6, and none of them seemed to be kind of true. And so what we wanted to know was, how was it? Next slide. And so rather than doing little measurements, we wanted big measurements. Millions of end devices every day, how are they going? And that's kind of an interesting question. You know, how do you measure millions? Like Atlas, and Atlas is good, but Atlas has around 10,000 nodes deployed, not millions, just 10,000. And they tend to be deployed in geek houses. No apologies to geeks, but their networks are different. Trying to understand what everyone does is a different kind of question. Next slide. So there is one way of doing this, and it's to be Google or Akamai or possibly Cloudflare or maybe Microsoft. You've got to be someone that everyone goes to. The problem is, as soon as that happens, you don't tell anyone. The data that they collect, and they collect a lot of data, is a secret. And so Google knows, but Google aren't telling. Next. So the other way of doing this is to actually leverage Google, because what you'd like to do is to have your own piece of code, whatever that code is, running on 1 million end devices every single day. Next. Now, what we wanted and where we started was this whole issue of trying to measure who's got IPv6. And what we wanted to say was not something about a few users that we sampled. We wanted to say definitively X% of users all over the planet are running IPv6. And we wanted to say it in such a way that we could talk about countries, we could talk about networks, individual networks, and we could do it day by day. So what we wanted was to actually sample users in a statistically meaningful way, to actually gather random collection of the entire internet every single day. Now, we stumbled across advertising networks, fortuitously really, next, because one way of doing measurements is to actually pay for it, just by the user. Next. And the thing about internet ads is everyone gets them. And I'll share you a secret, ad blockers don't really work that well. Ads are literally everywhere. They're ubiquitous, they're embedded everywhere. Next. And, no matter what you do, they're there, but there's something else going on too about these ads. You'll notice when you hover over an ad, often it changes. Next. Because inside an ad, and that's the ad that we run, bland as anything, because if you click, I pay. If you don't click, I pay a much, much lower rate. So if you see that, just let it go. Please don't click it. But that's all the ad is. Next. But behind it, as soon as that ad hits your browser, you don't have to click, this runs. And what the script does inside Google is it loads up a JavaScript, which we call HTML5 ad.js. Well, that JavaScript then just works in the background. Next. And the way this works is that we actually have DoubleClick, the advertising server, has next plopped an ad down on the end user screen. And then they just butt out of this. The end user is now running HTML5. Next. Now, what we do is we ask the user to get URLs. That's all. But if you think about what a get is, a get has to translate the domain name part into an IP address. Now, we make sure the name is unique. So when that domain name part is trying to be resolved, there's only one authoritative name server in your part of the world. We actually run 4, but in Europe, there's one in Frankfurt, in America, there's one in Dallas, etc. We see that query because this is a new domain name. Next. And of course, because it's a new domain name, it's never been cached. So the web fetch, even though it is HTTPS, the web fetch will definitely come to our web server. Next. And just to make sure we understand what's going on, not only do we see the DNS and we see the web server, but it's kind of important when you're looking for things that are missing to understand that the user didn't run away. So we do a final concluding fetch that says, I have retrieved everything that I'm allowed to retrieve and I could retrieve. I'm now butting out, which normally takes a 10-second timer. So you get what you get, and in 10 seconds it says, that's all over. Next. So what can we script in this measurement? Not much. Google, because of viruses and all kinds of badness that happens out there, limits most ads into being just a remarkably vanilla set of things. And what we do is simply get URLs. And the HTML5 is, of course, http.fetchImage, and all that does is just retrieve a URL. But if you think about what users do, that's what users do. They don't do anything else. And so users do a DNS resolution, and if they like the answer or whatever, they'll do an HTML fetch, probably using HTTPS. Now, as long as we make sure that everything about these experiment systems is uniquely tailored for each ad impression, every domain name's unique, etc., we get to see all the data. Next. So here is a typical URL that the user fetches. Now, this is the next piece of mind-bending stuff, because you've always thought that the DNS was a domain name lookup, where servers were merely almost like dictionaries. Questions came in, they served answers. But you can think about the DNS as a different way, as actually as microcode, where the query actually says an awful lot about the user and the behavior. So this is a lift from our experiment, a measurement experiment. 06S means this will only work if HTML happens in V6. It'll have A and quad A records, but only the V6 server will respond. 6S creates that behavior. The U code says we're going to do a bunch of experiments and they're all going to have the same ID, so that we can wrap those up and say, this is the aggregate of behavior for one user. And for DNS, we'll see a bit later, it's going to be important. A lot of folk are interested in countries. So as soon as we get the user handshaking with us, we load up a country code where we think they are. And so inside the query is actually the country code where we think they're located. The DNS has a huge amount of log replayers. Almost 40% of the queries we get are actually old queries from sometime in the dim distant past, or even from yesterday. To sift out what's active and what's a replay, we put the time of day in. So we only look at and answer experiments that are less than 120 seconds old. And last but not least, we haven't quite figured it out for V6 because the numbers are too long, but we can squeeze in the user's IPv4 address inside the query. So even the query knows which address we're dealing with at the endpoint. So that's a very typical kind of URL. We have other kinds of URLs or domain names that trigger large responses, that trigger fragmented responses, that trigger truncated responses, etc., so that we actually customize what the DNS actually does, including NX domain and serve fail, and simply just generate those. We can also play with valid and invalid DNSSEC signing. Next. So, ad placement. We tend to be cheap, and we tend not to get many impressions. So Google tries really, really hard to take our money because we bid low, and to make $100 off us takes millions of ad impressions. And so DoubleClick or Google work really, really hard to give us lots of unique clients every single day. Next. We started looking at this and actually looking at the unique IP addresses we saw every single day to see how Google actually did this. Were they just handing our ads to the same person, or constantly trying to hand us fresh users? Next. And what we actually see is that if we put the same code in a website, the same people go to the same website day after day after day. And so any kind of token measurement inside websites tends to be self-selection bias, that even if it's the weather, you only ever get to see the same users. Ads are completely different. But what we see in a cumulative sense is every single day we get a whole bunch of fresh eyeballs. So our sampling technique tends to wander through Google's entire database. Next. We run it quite high. We're currently placing around 6 to 7 million ads a day. Depending on the time of year and who else is advertising, over Christmas, New Year, it goes low because lots of other advertisers are there. Oddly enough, when the other advertising load drops, our ads go up to 20 million a day with the same volume of money. And so in some ways, the Google system is there just to take your money off the table. But equally, if there are lots of people bidding, you don't get as many ads as if no one else is bidding for those eyeballs. So we generally average between 5 up to 20 million impressions a day. typically between 5 and 10. Next. We actually did do a fair amount of back analysis to actually see where we were. There are a lot of users in India. They see a lot of ads. Similarly, Turkey. We were a bit worried about the United States, so we actually ran a special campaign just to bombard the US to get the numbers up. And so we try and keep the US at between sort of 500,000 to 1 million a day. But you can see the list there that we are actually trying to get a decent spread across most of the heavily populated countries. And Google's moderately good at that. Next. But in some ways, we don't get to see a uniform spread. And when we actually analyze the hit rate versus the user rate in a country, we see that some countries are overrated and some countries are underrated. In other words, Google overpresents for us in Turkey and underpresents for us in China, for example. And so what we need to do is actually take our raw measurements and compensate. Next. And so what we actually do, keep going, next, is actually apply a weighting to the raw numbers based on the ideal ad distribution, that were the ads distributed evenly across the world, we would get a subtly different one. So India, slightly over-presenting. So we multiply the number by 0.97. Belgium, I don't get as many ads in Belgium as a uniform distribution would suggest. The number is upped by 60%, 1.64, and so on. So every day we actually take the ITU's users per country data, compare it against the ad placement data, and try and weight our numbers to give us a theoretical even weighting of ads, even if the ads weren't evenly weighted. So this gives us, I think, a better distribution of what the world really looks like, as distinct from that slightly biased view of what ads look like. Next. From all of this, we take the logs of the web server, the logs of the DNS server, and we take all of the packet headers. So it's not a full packet capture, but it's certainly the first, I think, 80 bytes of every single packet. And this gives us individual DNS transactions, HTML transactions, but it also shows us the various DNS shuffles about what's offered, what's answered. For example, in looking at DNSSEC validation, we actually want to see what flags are being set in the query. It's got to have EDNS0, DNSSEC OK. It's got to have a query for the DNS, the DS and DNS key records. And we've got to see the user do a fetch for a validly signed name. But equally importantly, if the user is actually doing strict DNSSEC validation, if the name isn't correctly signed, they shouldn't fetch it. So to measure DNSSEC, for example, we use two separate ads. One is a validly signed URL, dual stacked, but the second one is invalidly signed. We want to see the DNS try and fail. So that gives us a review measure of DNSSEC. Next. So what do we measure? Almost everything. V6 adoption. With a careful look at the round trip time performance of the TCP handshake and do IPv6 performance. We've been adding extension headers to V6, watching V6 fail miserably. We've done a number of times packet fragmentation in the DNS for UDP, and we've got another measurement running right now where we deliberately pad out the DNS answer to cause fragmentation in both 4 and 6 and see which resolvers can cope with it and which fail badly. For this work here, we've been working on resolver centrality and performance. There's also DNSSEC validation, DNS over TCP, and so on. Next. So what are we seeing? Next. V6. India, Reliance Jio, rolled out for hundreds of millions of users a 464 XLAT solution, which is V6 native V4 overlay. India has one of the highest adoption rates in the world. China, despite their promises they were doing great work, is actually still around 10 to 15% growing slowly. Comcast and AT&T in the US have done amazingly, as has Germany with Deutsche Telekom and Kabel Modem, I think they're called, doing full rollouts. And similarly in the UK and in Finland and Brazil, There are hefty deployments in Mexico and Canada. Next. We can actually look at the V6 versus V4 performance. Now, this is a little bit ragged, but because we have dual stack clients, we know the round trip time in 4 and 6. We can compare the two. In some places in Central Africa where there is V6, it's terrible. Whatever the V6 path is not worth taking. The V4 path is far faster. But oddly enough, in other places, including Madagascar and parts of the sort of the stans in Central Asia, 6 is faster than 4. Same in Mexico, and same in Canada. Not sure why, but that's what we see when we straight out compare the round trip times. Next. DNSSEC validation. An odd set of numbers if ever you saw one. Certainly the Swedes led DNSSEC for years and actually offer a low priced or a discount on domain name registrations in .se if you include the DNS key, the DS records, in other words, if you're signed. But to look at validation, not registration, but validation, Saudi turned it on for the entire country. Geez, is that, no, it's not Azerbaijan, it's Uzbekistan turned it on. Mongolia, yes, I think that's Uzbekistan, somewhere around there. Mongolia sort of turned it on. And even though Comcast sort of had it on, there was a configuration error at the end of January. I took this snapshot and half of Comcast wasn't DNSSEC validating. Comcast is a dominant provider. When Comcast kind of do things badly or get it wrong, the numbers for the entire country go down. And so on that particular day, they did go down. Next. You can go further, although it gets rubbery. If you make the assumption that within a country, which normally has a pretty uniform socioeconomic background, the distribution of ads across consumer networks should be approximately even, because most ISPs try and service the same kind of population grouping as all the others. And so if you make that assumption that the ads are uniformly smeared and the only difference is the relative size of each of the ISPs, you can actually start to estimate the user population. Now, I'd say that's rubbery, plus or minus 5%, maybe even plus or minus 10%. But what it does show is most countries run 3 to 4 major ISPs in retail and then a bunch of littlies. And whether it's a large country like India or relatively small like Australia, you tend to see exactly the same kind of profile of who are the big players who make the most difference in the market and who are the smaller players. Next. This one, DNS resolver centrality. These are global figures. And what we wanted to know in this case is we're actually looking at what resolver do users use? Do they take the same resolver as the AS of their own provider? Do they go in-house? Or do they use resolvers in the same country? Or do they use any of the other open resolvers? So this is a global stat, and it says a little over half of the users send their DNS query to something in the same AS that then asks the authoritative. We're the authoritative, so we get to see. Around 40% ask in the same country, but it's not in the same AS, which again is not that unusual in some of these ISPs where the DNS is and where the users are might be in different ASs. The next number is Google. A little over 1/5 of the world's users across the entire world send their queries through all 8s. And the rest is the rest. Interestingly, China has a high degree, relatively to its population, a high degree of use of open DNS resolvers that are open in China and not used anywhere else. Like 114 DNS is one of the largest, but also DNS PI, PAI. And so the reason why they're in the top 10 is basically because there are a lot of people in China and they're using, to some degree of intensity, open resolvers rather than their ISP resolvers. But Google is certainly streets ahead of OpenDNS, and OpenDNS is still ahead of Cloudflare at this point in terms of intensity of use. Next. So I've gone as fast as I can, and hopefully I've left some time open for questions. But what I'm sort of trying to point out here is we can see what's happening at the user if we actually exercise the user to do it. And putting test code in there is one way of doing this. But I have to admit, I only see certain behaviors, and it's much harder to see others. So that's the last slide, by the way. In the context of measuring DOE, in the stub to recursive, I can't see it directly. What I can see, and have seen to some very small extent, is when Mozilla says, we're sending all the queries to Cloudflare, I can see a rise in Cloudflare in the US that is also tied against Mozilla. Why? The URL the user goes to has a browser SIG. I know it's Mozilla because they said it's Mozilla. When they did the fetch, they said, hi, I'm Mozilla. You can actually see the shift in the use of which open DNS resolver that set of users used. Is it a big shift? Nah. I don't think it's actually rolled out everywhere. I think users are lagging a bit. And I'm also not sure to what extent Mozilla have been aggressive in rolling it out. So it's not that obvious. But in other places and in other ways, much, much harder to tell because I just can't see the stub to recursive. If and when recursive to authoritative goes down the DOE dot path, this will be easy because at that point, this kind of technique is remarkably easy to use and will be quite informative. So I've used up my time. Any questions, please?
Excellent. Thanks very much, Geoff. Well, let me ask a question while people are thinking. On your penultimate slide, and I'll cheat because I can roll it back. Nice. It might be a dumb question, but you seem to add up to more than 100%.
Yeah, you know, what I'm trying to do here is actually make a distinction. And in the actual data, you'll see two of them in the data sets. I want to know your first resolver, and I want to know all your resolvers. Now, the way we actually get to uncover every single resolver you could use is every single response is serve fail. And the beauty of serve fail says, try the next resolver. And so when we hand back serve fail, it actually goes through all of the resolvers in your etceteraresolve.conf. And if there are multiple forwarder statements in the recursives, it'll go through all of those. So because of the serve fail thing, we're actually seeing your full set of potential resolvers. It's also uncovered some remarkably interesting behaviors. In October last year, for some users in some areas of the world, both Google Chrome and Chromium started round robining etceteraresolve.conf. Everyone else, it's strict priority. But for some reason, Chrome and Chromium decided, oh no, we're going to share it around a bit. I suspect the reason is because most folk use Google second. It's the backup. If I didn't get an answer from the primary, let's go to the backup. But as soon as the application starts round robining, the intensity of use goes up because it's no longer the backup, it's in rotation. So those kinds of things are visible, even at the stub to recursive, that the application behavior when it changes is actually obvious to us.
Okay, thanks, Geoff. All right, who else has questions? You can raise your virtual hand or shout out.
I have a question.
Okay, go for it, Brett.
Thanks, Geoff. It was really interesting, as always. One of the things I heard you mention during the presentation was replays of queries that happen after the fact, up to even a day later. And I've heard you mention that before, and I do wonder if you've got any theories about why that is.
The queries happen and are replayed up to, we've been running this experiment for 5 years, a bit longer, 6, and the replays are up to 6 years old. There are 3 kinds of reasons why we see replay. The first is demented resolvers. And there is a bug that gets exercised, and it might even be just a memory failure in bind, that we will see a single recursive resolver doing 2,000 to 3,000 queries per second for days on end. We had one in Guatemala that ran for a week. There was one in some academic network at the University of Maryland. So that's the extreme end. Just demented folk who've just gone nuts. There is the log replayers. Almost everyone in this business replays logs. Everyone. And a lot of this is DNS analytics. Some of it is actually used by the DNS vendors to actually stress test their resolvers. Others, like Blue Coat, seem to be doing some kind of security work. But log replaying at various speeds. Some of the folk, which I find a bit weird, actually use Google to do a log replay. They find a log and they feed it back through all eights. And Google has an enormous capacity. So we're doing up to 10,000 queries per second coming in from Google for old queries. And last and not least, there is the spooky bit, the bits that actually are DNS espionage. There are a number of applications, and the one that's most obvious we found some years ago is there is a Chinese browser, Chinese because it accepts pinyin input. Its name is Sogru, that whatever URL you go to, somewhere in China goes there as well within 2.5 seconds. Every new URL is tested. So, you know, those kind of three add up. Yeah. Currently, it is around 40 to 50% of our domain query load is older than 2 minutes. In other words, it wasn't done from the ad. I can only think that anyone who runs DNS, almost half of their traffic isn't real. But because the queries don't say where they're coming from, it's almost impossible to sift that out. The only reason why we can tell is the time signature sitting in the query.
Thank you. It's stuff like this that makes working in DNS extremely interesting.
Yeah, we've been forced to actually run an old query defender to stop them going through the rest of the engine, because the engines just simply can't take the excessive load.
Thank you.
Okay, thanks. A good question, actually. That's fascinating. Right, who else would like to ask a question? Simon?
I'll put a question in the chat, please. Yeah. Thank you, Geoff. That was a very interesting presentation. You noted at the start that this was to create, as it were, a public data bank. Do I take it that you're doing it in the name of APNiC, and that APNiC is the sort of authority that will hold the data and keep the public data bank, as it were?
So all of this data is online, live, graphable, and produces JSON data sets. So all of this data that you saw in the graph on resolver centrality, the data behind that, you can actually download yourself and play with it. What you won't get is the individual IP addresses of users. Google seems sensitive about that. I'm sensitive about that. You know, that's something that I cannot and will not share. But beyond that, data per origin AS, in other words, per ISP, data per country by day is available for download continuously. So it all comes off one sort of parent URL, but the entire data set is actually there, queryable and usable. So yes, the intent is to make this available data rather than just a secret. I will share that URL on the Eddie mailing list if you are interested, particularly the stuff about resolver centrality. You might find that of interest with this DO issue.
Thank you.
Okay, any other questions from people?
Greg Childs here, 3UK. One of the things that's possibly worth pointing out about mobile networks is that we reuse IP addresses. So the same IP address does not represent the same user all the time. They're very fluid all over the place because they're dynamically allocated.
Yes, yes, I understand. And we'll certainly have this a lot. It's not just 3 in the UK. Nigeria, we found a sharing ratio of 1,000 users on average per each v4 address. So yeah, it can get quite intense. This is the reason why inside the ad, we embed that unique identifier in the collection of URLs that gets presented to a user. So we don't rely on the same IP address as being, this is the signature of an end user. We actually rely on the fact that embedded in the URL and in the domain name is a substring that is exactly the same as the user for that user and different for all other users. So yes, we could in theory look at NATS-based concentration, which, as you can sort of figure out, we did do for some countries and found Nigeria was doing it more than anyone else. But beyond that, in v4 only networks, much, much harder to track what's going on. In v6 networks, there's not an awful lot of sharing going on. The v6 networks tend to be unique at the /64 level, because at this point, there's not an awful lot of natting. And so in the question in the chat room, is there a way to track unique users? Yes, there is. We could go further, but we have refrained. One of the ways to go further is to actually use WebRTC. WebRTC is a remarkably, I'd say chatty, but I think it's worse than that. It unleashes a huge amount of local information, including the local IP addresses on the local interfaces of the end device. And it will happily send it back down the wire in HTML5. So, you know, we did try it years ago and were appalled at the amount of information we got, which we shouldn't have got. But is there a way to do tracking this way? I think there is. Do we do it? It's none of our business. We don't do it.
That's a slightly scary answer, Geoff.
WebRTC went too far in my view, but yeah.
Yes. And I think Simon, you've probably seen in the chat his observation that governments and corporates sort of share IP addresses as well. I'm not sure.
Interesting thing there, though, is government and corporate use and the amount of ad penetration. Every worker bee gets bored. Every worker bee watches YouTube. Every single office, every single area, and ads are pernicious across the entire internet. It is honestly appalling in some ways how far the ad system actually penetrates.
Do you find any firewalls effective in blocking some of your data, Geoff?
Yes, we do. And interestingly, a lot of the firewall work, the original work was in firewalls that didn't like various forms of IPv6 tunneling, 6-4 and Teredo. We certainly were able to sort of look at a 35% failure rate for Teredo because of firewalls. What we see now is subtly different, but equally disturbing. Any kind of large v6 packet has an astonishingly huge drop rate. In the DNS itself, around 35% of DNS resolvers do not receive a fragmented v6 UDP packet. How do we know that? I didn't quite go through all the hints and tricks in the DNS that we use, but I can actually tell if you get the DNS answer that I gave you, not by the URL fetch, but by using an odd technique called glueless delegation. I give you the name of the endpoint you need to go to. You need to resolve this name. And I give you the name of the authoritative servers for that name. But I'm not going to tell you their IP address. You have to find it. So when you search for the name of the authoritative server, I hand you back a really big packet. Really big. It's padded out like crazy. Now, I know if you got it or not, because you're only going to ask the question that you were going to ask, if you will, the ultimate question, if you got the answer to the intermediate problem. And that lets us sort out very, very easily and very accurately just what resolvers can do what by posing these glueless puzzles in the DNS and actually understanding to what extent those glue answers make it to the end or not.
Interesting. Okay, any other questions for Geoff as we're running towards the end of our allotted time? I'll take silence as not. In which case, any last thoughts from you, Geoff, that you wanted to add before we close?
As I said, this one is kind of tough for us because certainly we've tried very, very hard to see inside the user to the recursive. And this particular question, we can only see indirectly. I am looking forward to the inevitable position where this comes in on recursive to authoritative. And there are some early experiments in that, and we're certainly interested in becoming a known authoritative server on DO and DOT to see to what level recursives take this up, and then at what point we can play around with that to understand who, where, why, and how of the take up in that next step. We're also keenly interested in understanding the true horror that is resolverless DNS if that ever comes up. Because don't forget, we're running inside the browser. If resolverless DNS ever comes in, we'd actually be able to play with it inside the ad, which is both scary and interesting at the same time.
Brilliant. Okay, well, that's maybe a fantastic thought to finish with. It was occurring to me that anyone that has any privacy concerns around ads, I think this will really educate them, and because obviously a lot of advertisers will not be so inclined to discard that privacy betraying material as you and your team are. So it maybe
Yes.
just goes to show how much information can be sourced from ads in browsers.
I have another question, if I can sneak it in, Andrew.
Go on then, just under the wire, Brett.
Geoff, I was wondering if you're either already doing or planning to do any tests around the changing behaviour of the entire world working from home.
We've been looking at that, and that was actually the other part of the original Comcast posting that I made. Because you notice in a number of networks, and Comcast is absolutely indicative, that there's a weekday and a weekend profile. During the weekday, V6 is down and the use of Google's public DNS is up. On the weekends, there's more V6 and less use of Google. Over Christmas, just to confirm this, we see the same trend, that across Christmas, V6 goes up, the use of Google goes down. Now, there are two ways of working from home. One is you actually VPN back into your corporate environment, and that if you will, Comcast or the local end loop don't participate in this, the profile is the same. The user appears to Comcast as a corporate user, or they're using the home network. What we're actually finding in Comcast is that the profile is smoothing out, that weekdays and weekends are looking the same. And so disturbingly, what that means is there are a lot of folk working from home, but the worry is I don't think they're using VPNs or telelocation. They're actually working from home in the home environment with the home DNS, the home stuff. And they're not actually, if you will, making that first hop back to base, back to the employment and outwards. They're actually working from home. And so that's the first thing that I've seen.
Well, that's interesting, and that could be an indicator of the amount of corporates are using cloud-based services these days, and therefore they don't need to be on a VPN because they're using cloud services so much.
That could well be it, Brett. I don't have enough insight to see what else they're doing on their screens. But what I do see, though, is that the profile of use is closer to the weekend than the corporate world. So whatever they're taking home with them doesn't include the DNS and the web. That's just native.
I think I can offer some perspective from Nominet's point of view, and that's exactly what we see at Nominet, is most of our staff don't need to be on a VPN anymore. They're using cloud-based services mainly. There's a few select applications that we run in-house, and those users have to be on a VPN to use them. But again, they're on a split VPN, so they only get routing for certain things across the VPN, and everything else goes across the internet.
Right. So, yes, as I said, it was quite pronounced in Comcast, and I think it was because a question came from Comcast I looked. But, you know, if any of you have suggestions as to which networks to look at, I'm quite happy to either share the data or look myself to see if other networks that sort of have large retail presence in, you know, home users as well as corporates have a similar kind of shift in their profile of use.
Can I jump in for a second?
Sure.
As just what you were talking about, I was thinking it's not just people working from home, there's lots of kids at home. I know I've noticed an increased amount of like gaming traffic and traffic related from non-corporate users. But I had a question as well as a comment, which was, you mentioned ad blockers aren't effective. What's your perspective on that in 2 words or less? No, I don't mean that seriously. What's your perspective on ad blockers?
I think ads are pernicious, distracting, and an absolute pain. But on the other hand, that's my life at the moment. So, you know, we all should run ads. I have a very split view on this. I've managed to bend ads in a way that I think creates an outcome that Google wouldn't have shared this data with me any other way. Akamai won't let me look over their shoulder. None of the biggies let me look. But DoubleClick is the dominant ad platform for the planet. And being able to do this through DoubleClick is incredible. I think it's just a unique opportunity. I'm impressed how far I see inside China in particular, but inside almost every single country, you know, it has quite a deep and clear vision. So from that respect, you know, don't condemn ads completely. They can be useful.
Could your data be used to make the ad blockers more effective, do you think?
I'm just DoubleClick. I don't think it could be, you know, bent that way.
Okay, thank you.
All I'm doing is just running through Google's end user database, you know, that presents new users. So if I cared to, and I looked hard for a year or two, I'd actually reconstruct their entire end user database. But, you know, I'm not sure I really want to do that. And I'm not sure Google would want me to anyway.
Yeah, not so much.
Not so much.
Brilliant. All right, well, that's fantastic, Geoff. Do appreciate you taking the time out of your evening in Canberra to share with us. So thank you for doing that. And I'll put the recording up, probably be later on this afternoon or tomorrow morning for everyone.
Okay, and I'll share the URL where all the data is for anyone who is interested on the same EDDI list.
Please. Thanks very much. And thanks everyone for joining.
Thank you.
Thanks.
Bye.
Thanks all.
Bye.
Thanks for
Thank you.